How does friction factor impact pressure loss in pipes? Imagine water flowing through a pipe and feeling resistance as it moves. That resistance is caused by friction between the water and the pipe wall. It might seem small, but it plays a big role in how much pressure drops along the pipe. When fluid moves through a pipe, friction acts against its motion, converting some of its energy into heat. This energy loss shows up as a pressure decrease as the fluid travels further. To understand this better, we use the Darcy-Weisbach equation, which links the pressure loss to the friction factor, pipe length, diameter, fluid density, and velocity. The equation looks like this. Pressure loss equals the friction factor times the pipe length divided by the diameter, times the fluid density times the velocity squared, all divided by 2. The friction factor itself is a number that tells us how much resistance the pipe wall creates. It depends on whether the flow is smooth or turbulent, how rough the pipe surface is, and the properties of the fluid. In smooth, slow-moving flow, called laminar flow, the friction factor is simple to find. It equals 64 divided by the Reynolds number, which measures flow speed and viscosity. When the flow is faster and turbulent, the friction factor becomes more complex. It depends on the Reynolds number and the pipe's roughness, and engineers often use charts or empirical formulas to find it. As the friction factor increases, the pressure loss also rises for the same flow rate and pipe length. Rougher pipes or turbulent flows cause higher friction factors, leading to more pressure drop. This means that designing efficient piping systems requires knowing the friction factor accurately. It helps engineers choose the right pipe size, pump power, and flow rates. Larger pipe diameters reduce flow velocity, lowering the Reynolds number and the friction factor. Longer pipes increase total pressure loss proportionally. In real-world applications, calculating the friction factor allows engineers to predict pressure drops and design systems that use energy wisely. Whether moving water in a building or oil in a pipeline, understanding how the friction factor impacts pressure loss is key. It ensures systems operate smoothly without wasting energy or causing equipment to work harder than needed. So, the friction factor is a simple yet powerful number that directly influences how much pressure drops in a pipe, shaping the efficiency and performance of fluid transport systems.